This video aims to serve as an introduction to completing the square. We're going to look at quadratic equations in the form ax squared plus bx plus c equals 0, where a can take any value, and the method of how to turn these into what we call completed square form. It's just this method we're going to look at in the video. In the follow-up lesson, we will use completed square form to find properties of quadratic functions, including minimum and maximum points. So what do we mean by completed square form? Well, the process changes our quadratic equation into something that looks a bit like this. So we'll have a quick look at the process where we look at the x squared term and the linear x term, and we take half of the coefficient of this linear x term here. So because we've got single x squared and we've got plus 6x here, this becomes x plus 3 in the bracket. So that's the first step. So we draw a bracket and we put x plus 3, and that's our linear bracket squared. If we multiply out this bracket, remembering the expanding brackets that we did last lesson, we use the FOIL method. We get x squared, then remember it's the outside terms, plus 3x plus another 3x, and then finally the last terms to complete the smiley face, plus 9. Looking at this, we can see here that we've got x squared plus 6x, which is what we've replaced here, but we've got an extra plus 9. So we deal with this by subtracting 9, and then don't forget we've still got that plus 13 on here. So in other words, this part here replaces the x squared plus 6x. Because it creates an extra 9, we subtract 9, and we're always subtracting the square of this second constant here. So the constant, the second term in the bracket, that's what we subtract the square of. And that's always the case, even if it's x minus a constant. And then to tidy up, you can see here we get our x plus 3 squared minus 9 plus 13 gives us plus 4. Right, so with the last example, we had a single x squared. You can see here we've got 2x squared, so we have to do a little trick here. We're going to take that 2 out, and then in a big bracket, we're going to take it out of every term, so you can see here now that we've taken the 2 out. Now we can complete the square for everything that's inside this square bracket here, and we get, remember it's half the coefficient of the linear part, so it's x plus 2 squared. If we multiply this out, well, I'm not going to go through it all again, but if you're not sure, do that yourself. Use FOIL, multiply it out, and you'll find you get x squared plus 4x plus 4. So we need to subtract the square of the constant term, and we've also got minus 2 there. So we end up with 2 lots of x plus 2 all squared minus 4 minus another 2 gives us minus 6. We can now multiply out, well, leave that in completed square form, that's what we want. But don't forget this minus 6 here is also multiplied by 2, so that becomes minus 12. And in the lesson, in the follow-up lesson, we'll have a look at how we can use this form here to give us important properties about these quadratics, which are much harder to find from an equation in this form here. Right, now have a go at the quiz, answer all the questions, and then you'll be ready for the lesson.